Hello YouTube, today I'll be telling you how to make some CCTV footage. Basically just a really simple recording software that only records whenever movement is detected, and it can be really easily set up to detect whenever within a certain time or whenever a button is pressed. That way whenever you're out of the house it can start recording if movement happens. So let's get into it. So first I have a new file. I'm going to go ahead and save it, and it's going to be, there's a few different Python projects. So basically I created a YouTube folder, and in that folder I created a CCTV folder, and then I'm going to save it in this. Now an important thing to say to create another folder for is this output_files. This is going to come into use later. So I'm just going to name it something like cctv.py. And then from here what we're going to do is we're going to get our imports done. So let's see, we're going to go ahead and import datetime, because we're going to need the time later. Then from CV2 we're going to import that, and then you can just do import CV2, but I like not having to type CV2 dot every time I use something from CV2. And then we're going to need to import numpy, and I import it as np. Oops. And then another important thing we're going to need to do is we're going to need to import the OS. Alright, so first up we're going to want to create a video capture. Just going to create a variable, call it video, and then put video capture as the argument. Anyways, next we're going to do we're going to need to grab the frame from the video. So I'm just going to do underscore, comma, frame. Basically, we don't need the first argument for the video.read function that we're calling, but we do need the frame. So this is just not really going to be used, so I'm just going to label it as underscore, and then we just need to get this frame. And then what we also need to do is we need to have a last frame. This is going to come into use later, and we're just going to store that as frame currently. A threshold, basically what this threshold is going to be used for, I'm just going to set it to real quickly 450,000. You can set it to different numbers, but this is the number that we're really going to need to be messing with. We can alter it a little bit. Basically, this threshold value is going to be the amount the pixels change from the current frame from the last frame. And you're going to see how that plays in here in just a little bit. But right now, I would say just leave it about 45,000 or 450,000. But you know, it could be likely to change. Then what we're going to need to do is we're going to need to make a record buffer max. We're also going to create a record buffer variable. I'm just going to set that to 15. It should be for 15 frames, and then a current record buffer. Set that to 0. Now, what we also want to do is whenever it is recording, we want to save it to a file and output it. So for that, we're going to need to create a function called 4cc. Now, I'm going to be completely honest with you. I have absolutely no idea how this works. I'm not even going to try to explain it because I don't know how it works. I'm actually pretty new to Python myself, but I know this is how you save video files. So this is what I'm going to do. I recommend you copy it if you want to follow along. If someone has an explanation, feel free to drop it in the comments. But otherwise, I would recommend just following this. And this is where this output files is going to come into play. You can see this is where we're actually storing the file. You know, while I don't know a lot, I do know some. All right, and then basically all this is going to do is this is getting the actual file name for us, and we're just going to store it in numbers. So basically, we're getting the amount of files in the output files folder. And then if there's no files, then it's going to store it as a file that's like a 0.avi. Or if there's 3 files in there, it's going to do it as 3.avi, or I guess would that technically, yeah, that'd be 3.avi. So then we're going to do the output, which is going to be video writer, and then we're going to do output files. And basically all this is doing right here is going to the current directory that the cctv.py file is stored, going into the folder, finding output files, and then what we're going to do is we're going to do str, basically converting this to a string of num files. So before this is an int, we're just converting it to a string. Pretty basic stuff. I'm not even sure if that's needed, but I'm not really going to test it right now. Then we're going to drop in our 4cc, the video format that we saved right up here. And then from there, we're going to give it 30, and then int video.get3, int video.get4. Now, once again, I could be horribly saying, or like I could be butchering the reason behind this, but to my knowledge, this is getting the width and the height and storing that in the video. That way we can actually save the correct number of pixels. So now we can get to the actual, the whole computational part of it. So we're going to create a while true, and then from there we're just going to start the datetime. That way later on we can read the datetime. Oops, forgot the equals. And then we're going to go ahead and call the video.read again, just that way we get a current frame. Video.read, and then we're going to create a variable called NetDifference. And this is going to come into play here in a little bit. Basically all it's going to do is up here, this is the threshold that shows the difference, the difference that needs to be met in order to say that a picture is moving. Down here is basically storing the actual amount of difference from frame 1 to frame 2. And then it will reset that each time, which is why we call the variable up here. Then I'm going to set everything to grayscale. It just helps a lot with the whole differencing. And all we're going to do with that is color. So CVT color, and then in there we're going to pass through our frame, and then color blue, green, red to gray. And I say this as gray cur. I do kind of weird naming conventions, but basically gray current frame, and then gray underscore last for the last frame. And then we're just, CVT color. And then we're just going to pass in our last frame, and same thing. Color blue, green, red to gray. Pretty simple stuff. So now we're going to need the difference between the two. So I just create a variable called diff, and then do subtract the current frame from the last frame. And then I believe you can do this all in one line, but like I said, I'm pretty new to Python, so I'm not entirely sure. I tried to do it in one line, it didn't really work, so I'm not sure what all that is. Basically, all we're doing here is getting the width and height of the of this difference, because this difference isn't its actual own frame. Same as we have the current frame and the last frame. This is actually its own frame. It's more picture, really. So basically, what we're doing with this numpy.size is we're getting the width and height. That's why we have them as W and H. And then from here, we're going to create a nested loop. So for range for I in range 0 through width, and then for J in range 0 through H. And anyone who's kind of experienced with programming can know you can switch these up however you want. I just prefer I and J, but they look a little similar, so some people I know really don't like that, but it works for me. So, and then mod of 5, I of mod of 5 equals 0, and J, let's see, where's the, Jesus, all right, and J mod of 5 equals 0. And basically what this does, I was having a bit of problems whenever I was working with this because there's so much computational power being needed that I just did every 5th pixel rather than every pixel. It really frees up a lot of computing space, makes it go a lot quicker. And then all we're going to need to do here is get the difference from I and J. So basically what this is doing, this is, since this was in black and white, and then you're getting the difference, so basically this is only going to be, if the pixels are very similar, it's going to be a very, very dark color, very close to black in this diff image. And if they're very different from each other, like one pixel is very bright on one and the other one's very dim on the other, it's going to output a very bright signal because it's difference. And basically all we're doing here is for, here we're getting the every 5th pixel. For every 5th pixel in diff, we want to get the actual color. So we're just getting the red, green, and blue values. I and J. You know what? Actually, thinking through this, we might need to not do this because it is diff. I'm not sure if this is a little overkill actually, because it took a lot of testing to do this. So if we actually don't need this, where we're getting the red, green, and blue values, I'll edit that in or leave a comment in the description so you can actually just do one specific thing rather than all 3. So I'll figure that out after the video. And then we're going to use this NetDifference function that we have, and we're just going to add red, green, and blue values. And basically all that's doing is getting the difference from these red, blue, and green values. The more I think about this, the more that I don't think it's needed, but I'll figure that out later. And it's getting the amount of difference from each of those and then adding that to the net difference. So what's going to happen is once it's run through every single pixel in the image, and then for every fifth pixel, it's added to the net difference, then we're going to have a total value of the net difference between the pictures, because it's going to tally up how many light pixels and how many dark pixels they are and how much that value actually is. Alright, so then we're going to create a frame called difference. It's actually one of my favorite things about this program, is that it looks really cool. It looks like one of those old filters that you'd get on like an old like a really old laptop, and it'd be like one of the preset filters you can do with a camera. It's actually pretty neat. Yeah, I just like to mess with it more than anything. So then what we're going to do is if net difference is greater than threshold. So basically only if the actual movement is greater than what we're going to do, because anytime you use a webcam or any camera in general, it's going to detect small little differences in the way that it just captures light, and that's why we have this threshold. That way, because no matter what, no two pictures you're going to take with the camera are going to be exactly the same. That's what this threshold is really used for, to make sure that that difference isn't too noticeable, and that way the camera can actually like understand the fact that there's actual movement and non just like static. So then what we're going to do down here is we're going to turn this record buffer, and we're going to set it to record buffer max. Basically all it's going to do is give us a little bit of extra time to record. That way we know what's happening even after the image has gone still. So then what we're going to do is we're going to create a rectangle, and we're going to put this in the frame function, and we're going to get the width, get to 0. And then we're going to mine. This is just a value that works for my camera. You're going to have to play around, but I know these values work specifically for my camera. That way I can get it right in the bottom right corner of my camera. And all this is going to be right here that we're making is going to be a timestamp. Alright, so basically what's happening here is we're creating a rectangle within the frame. And we're getting the starting position and the ending position via these, getting the width and height of the frame itself, and then that's the starting position and this is the end position, and we're doing a little altercations to it via just some subtractions to the width and height. That way we get the exact size that works for my computer. Like I said, you're going to have to play around with it a little bit. Then we get the color, and then we get that it's filled. And then inside it we're going to put some text. So we're going to do put text frame, same thing. It's basically all we're going to do is apply this text to the actual frame image, and then we're going to do now dot strf time, and then it's kind of a little weird syntax, but we're going to do percent lowercase d percent lowercase d, then we're going to put a forward slash percent lowercase m forward slash percent capital Y, and then we're going to do a space percent capital H, and then we're going to do a colon percent capital M, and then another colon, and then percent capital S. And basically all this is going to do is give us the date, month, and year as divided by slashes, and then hours, minutes, seconds. And then same type of thing, we're going to get the actual location for it. And then this this font right here, the font Hershey Simplex, all this is going to be just the basic font that we use. We're going to give it a size, and then we're going to give it a color. And then I believe this is like the strength of the stroke. I believe. I could be wrong on that. I'm not 100% sure. Like I said, I'm still pretty new to OpenCV and especially new to Python. And now here we're going to do if record buffer is greater than 0, basically indicating that we are actually wanting to record. This is so long the net difference is over the record buffer, or I'm sorry, is over the threshold. Then we're going to put text in the top right. And we're going to go frame, and then we're going to do not moving. And I misspoke. This is if the record buffer is less than 0, not greater. Then not moving. Then we're going to give it a location of 2020. We're going to give it the font of Hershey Simplex, a 0.6 size. We're going to give it. I like to give it a red. That way it indicates something that's not negative, but it's very clear. And then below it we're going to do else. And I'm just going to go ahead and copy this because it's a very similar line of code. Paste that right there, and then all we're going to do from here is change it from that red to green. Like I said, not indicating that something's good or bad, but it definitely indicates that something's happening in a very clear way. And then that is going to change that to moving. And then, yes, inside this else, what we're going to do is we're going to do out.write frame. Output. And this is what it's going to do, is it's going to use this, and it's going to save our files and store it as a video. And then we're always going to want to change the record buffer minus equals 1. I'm used to C#. If someone can explain, I usually do that, but it doesn't seem to work in Python, so you do that. So from here, basically all this does is every single iteration of this while loop, it's going to minus down record buffer. That way, if this never gets called, the record buffer just goes into the negatives, and this stays at not moving. Okay, so then what we're going to do is then if record buffer, let's just say is less than -100, we're just going to set record buffer equal to -100. This is going to basically keep it from going into infinity, into the negative direction. Then we want to do IAMShow, and then we're going to pass through our name for the frame, and then just call it frame, and then we're going to pass through frame. Then we're going to make sure we assign last frame to the current frame, and then we're going to create a statement. That way we can go ahead and break it if need be. So we're just going to do wait key, if wait key 1, and 0xff equals ord. Use the character Q. Oops. And then we're going to go break. And then now that once that breaks, we're going to do video.release. Oops, that's not release. Video.release. We're going to do output.release. And we're also going to do destroy all windows. So this is gonna, whenever we press the Q button, I'm not sure why this is, but this is what I've always done. It's gonna break it, and it's gonna break this while loop, and then it's going to do video.release, output.release, and destroy windows. Basically, making sure that we don't have anything else running while the program is actually finished. So we're gonna go ahead and save that all, and we're gonna run it and build it. Sometimes it takes a second to load up. All right, we ran into an error. All right, so I should have fixed it. I just forgot an extra parentheses right there. Go ahead and build it. More than likely, yep, I would say usually I run into an error of some kind. Oh, I know exactly what that error is. I thought it might happen. So up here we just have to do from datetime import datetime. And then, let's see, run into another error. Let's see. Usually this happens a lot whenever I'm building programs, so it's not a big deal. Get is not defined. Oops, that'd be why. I used a comma instead of a period. Let's go ahead and build that. Let's see what happens. You can probably hear my cat in the background. Have another error. Font Hershey simplex is not defined. I forgot the E right there. That will do it. And then I used Hershey simplex in a few other places by copying that. Build it. Whenever you're moving down the error list on the bottom, it's good. All right, and wait key is 1. Wait key is not defined. Oh, that needs to be a capital K. And let's see here. All right, wonderful. Not quite. So now you get to see my face. So as you can see, there's a little problem with our rectangle. It's a little wrong here. You see my cat in the background, but the rectangle isn't all that important. I'll fix that in a second, so I'll show you what it actually should be. But as you can see, right here is our frame, and in the top left you can see I am moving. But what's interesting is this part on the right, this difference frame. And you can see this is where you can see that the computer's actually like seeing and thinking. So if I stay still for long enough and don't talk, you can see that the screen turns black. Basically, it's noticing that the frames are getting too similar to each other, and there's not enough difference. And then every single pixel that's different from the frame from the last that's what's being shown as white. That's why the background's so black, and I'm so like brightly lit up. But like I said, if I were to stay still, if you look at the top left of the frame, you can see it says not moving because I'm not moving. But as soon as I were to shift left and right, the computer detects that there's more whiteness going on. And because of that, there is it's going to stay as moving, and then even once I stay still for a second, it's going to stay moving, and it's going to say that's recording. So now we're going to go into this frame, and we're going to press Q just to go ahead and quit it. And then real quick, let me see if I can't tackle this this rectangle problem real quick. That'll do it. All right. So first what I did is I changed this 40 to a 70. Must have just mistyped, and this is get 0 is supposed to be get 3. So that's my bad. And now if we go back and look at it. yeah, it's perfectly lined up that way. No matter even, let's see, even if something is behind it, it's always going to have a clear date and time, which is very nice. And then we're going to go ahead and quit this. And then now if we open up our CCTV folder, we have this output files folder. And in here, you can actually see the stuff that's saved. Now this is up from our failed thing. So what I'm going to do is I'm just going to go ahead and delete all of this real quick. And then my cat's being loud back there. And then if we go ahead and build again, and we move around for a second, make sure you note the time. So I'm going to stop here in a second. I'm going to let it stay for a few seconds. And then that was for about 2 seconds that it stayed. And what's important to note is whenever we look back at the file, that time's going to jump because it didn't save whenever it wasn't not moving. So we're going to go ahead and do that, load up the output files, and here we have file 0. That's what I was saying. It's going to save it as 0.avi and then 1.avi because it detected that there were 0 files in here. It's going to save it as 0. So now if we open it up, and it records a little faster, but if you watch, I don't know if you saw it right there, but it went from 37 to 40 because it was 3 seconds of non-moving time. But if you look up here, it's going to stay as moving, and it's that's probably because my cat set it off more than likely. But yeah, so it saves a little quicker. And I'm sorry for kind of like the rough explanations for this. Programming is not really my strong suit. I've been doing it for like a decade, but even still, I'm not the best at it. It kind of works in my own brain the way it works, and it's kind of hard to get it out sometimes. So that's how you create a CCTV footage, basically. Simple recording software. You can set this up for a security system easily. And now I'm not going to say it's going to save you from anything, so don't come to me if your house gets broken into because of it. But it's that simple recording software that you could have set up. You could put this on a Raspberry Pi and just stick it in the corner of your room, and then it would be easy to say within if the hour was anywhere from 20 to 4. Basically, that's an 8-hour window of, what is that? 8 at night to 4 in the morning, or you could do 20 to like 6. That's like a 10-hour window. That if there's any movement in a certain area of your house during this time, it's going to record it. Now that could be a cat, that could be anything, but my purpose is going to be having it up in a dorm room, and then I have a few other security systems built in. That way, I can monitor my dorm room to make sure that no one's breaking in. So yeah, I hope you all enjoyed the video. If you'd like more of these videos, please let me know. I hope it helps. Thanks.